Hello students, welcome to this particular session. We will have a very important discussion on the types of motion. In the previous lecture, we have discussed about motion, rest, 1D, 2D, 3-dimensional motion, isn't it? So motion basically, I must recollect that definition for you. Motion actually means a body changing its position with respect to its surroundings with the passage of time. So that's when a body is said to be in motion, right? There are various types of motion actually. So motion can be broadly classified into two types. One is the uniform motion, the other one is the non-uniform motion, right? Non-uniform motion can be further categorized into two types. One is uniformly accelerated motion and the other one is non-uniformly accelerated motion. So we'll discuss all these topics in detail. So in the present session, we will only concentrate on this particular topic, uniform motion, right? In order to understand these topics, we need to first understand the concept of acceleration. That we'll discuss in the later section, right? For now, let's start with uniform motion. Uniform. So what's the meaning of uniform? Literal meaning of uniform means constant, do not change. So that motion of a body which do not change, which remains constant. In this sense, it covers equal distances or displacements in equal intervals of time. So it is only in that case the body is said to possess uniform motion. So again I repeat, a body is said to possess uniform motion only if the body covers equal distances or equal displacements in equal intervals of time, however small the time intervals may be. Now, I have used equal distances or equal displacements. Students, always remember, we are dealing with motion in one dimension. When a body moves along a straight path, the distance of a body is equal to its displacement. So, equal distances or equal displacements. That's why I have used the term or, right? So whenever a body covers equal distances or equal displacements in equal intervals of time, then it is the case of uniform motion. Now students, think over it. When a body is going to cover equal distances in equal intervals of time? Yes, it is only when the body possesses constant speed. Its speed shouldn't vary, it should have constant speed. If a body possesses constant speed, then only it can cover equal distances in equal intervals of time. Right? In case the speed of a body varies, changes with time, then the body in no way can cover equal distances in equal intervals of time. That will be the case of non-uniform motion. That we'll discuss in the later section. So coming back, uniform motion. What are the important properties? For a body to have uniform motion, first is its speed, or in one dimension, speed. In one dimension, speed is equal to velocity. When the body moves along a straight path, it is constant. It will not change at all. So this is the most important concept, right? Then, regarding its position time graph, it will be like this. We'll discuss it in detail. Position time graph. It will be like this. This is suppose position represented by x and this is time t. It will be like this. A straight line inclined towards the time axis. Right? We'll discuss about this graph in detail right in this session only. Here I am just mentioning the important characteristics of a uniform motion. So, position time graph of a body having uniform motion is a straight line inclined towards the time axis. X is the position, t is the time. Velocity or speed time graph. It should be like this. Time, this is speed or velocity. It should be a straight line. Because with the passage of time, the speed of the body or velocity of the body will remain constant. It will not change. So, if a body possesses uniform motion, then its velocity time graph is a straight line parallel to the time axis. Right? I'm repeating these 3 points. Right? We'll discuss these graphs in detail. I'll show how to plot these graphs and what's the significance of this graph. That also we are going to discuss right in this session. For the time being, we are simply theoretically discussing the important characteristics of uniform motion. So what we have discussed is, a body is said to be in uniform motion if it covers equal distances or displacements in equal intervals of time, however small intervals may be. And what are the characteristics? First and foremost, for a body to have uniform motion, its speed should be constant. Here I have written speed or velocity. Why? Because the body is having one-dimensional motion, moving along a straight path. When a body moves along a straight path, its distance is equal to displacement, and accordingly speed of the body would be equal to its velocity. Only in one-dimensional motion, when the body moves along a straight path. Right? Second important characteristics, the position time graph would be a straight line inclined towards the time axis. Third important characteristics, velocity time graph is again a straight line but parallel to the time axis, signifying that velocity is constant. And students, I would like to mention one more important point. For a body to have uniform motion, it shouldn't be under the influence of any cause or any force. No force is acting on the body. It is only then the body can be in uniform motion. This we'll discuss after we go through the topic of Newton's laws, right? For the time being, just remember, a body can have uniform motion only and only in the absence of any external force, right? So for a body to possess uniform motion, no cause, no force whatsoever is required. Okay, let's start with these characteristics. Let's study these characteristics in detail. So what we'll do is, we'll first discuss position time graph, right? So let's assume a situation where the body starts from the origin and the body is moving along a straight path with speed of or velocity of say 10 meters per second, right? This is constant. For a body to have uniform motion, the speed must be constant. That's the mandatory compulsory condition, right? So we are supposed to plot a graph between position and time. So what we'll do is, let's prepare a table before plotting the graph. Okay. This is suppose x, it is in meters. This represents position and this is time, suppose in seconds. In order to plot a graph, at least 3-4 coordinates are required. Then only we can plot a graph, isn't it? So at t equals to 0, t equals to 1 second, t equals to 2 seconds, t equals to 3 seconds, t equals to 4 seconds, and so on. Initially, suppose the body is at origin, so x would be also equal to 0. After 1 second, what would be the distance covered by the body? Look, distance is speed into time. This is the formula. Distance would be equal to speed multiplied by time. So after 1 second, what is the speed? It will remain same throughout the duration. So 10 is the speed and time is 1 second. So it will be equal to 10 meters. So it is 10 meters. Right? You need not to write the unit over here. It's already mentioned over here. After 2 seconds, what will be the distance covered? 10 into 2, that will be 20. After 3 seconds, distance covered would be speed into time. 10 multiplied by 3, that is 30. Similarly, after 4 seconds, it will cover a total distance of 40 meters from the origin. Have I made myself clear? So let's represent these points on a graph. So this is time. Don't forget to mention the units in which the physical quantity is being represented. This is the position. Maybe in meters from x axis. This is the origin. Equal intervals of time. 1, 2, 3, 4, 5 and so on. These are equal intervals of time. Ensure the gap between them should be equal. or it is preferable to draw these graphs in a graph paper. Then suppose it's 10, this 20, again equal intervals of time, equal gaps, 40 and this is 50 and so on. Okay, first point is 0, 0. This is where the first point lies, is 0, 0. Then 1, 10. 1 and 10. That's the ordinate abscissa. This is 1, this is 10. Right? This is the point. 220. Time is 2 and this is 20. Time is 2 and this is 20. This is the point. This is 220. Right? Third is 330. This one is 3 time axis and position is 30. So draw a perpendicular over here and over here. They will intersect at this point. This will be 330. This is the point. Encircle it. 440. This is 4 and over here it will be 4. This is it. This is 440. These are the ordinate and abscissa. Now if you join these lines, obviously it would be a straight line. Obviously it would be a straight line. All these points will lie on a straight line like this. So what we have proved is, if a body is having constant speed, that is, if a body is moving with a speed which is not changing, right, neither in direction nor in magnitude, then the body is said to have uniform motion. And if the body pauses uniform motion, then its position time graph is a straight line inclined towards the time axis. So students, that is what we have proved over here. Right? Now let's concentrate on the significance of this graph. The significance. Now look, this being a straight line, the slope is constant. Slope. This is known as the positive slope, this is known as the negative slope. Uphill, this is positive slope. S-L-O-P-E, slope. The formula for this slope is y2 minus y1 divided by x2 minus x1. This is the formula. If this is considered to be y-axis, this is considered to be x-axis, then this is the formula. That also I will derive it for you. What we do is, slope in this case will give us position, that is, y coordinate, it represents the position, which is position x2 minus x1. And x coordinate is representing time, that is t2 minus t1. So it is basically displacement over time. In time interval t2 minus t1, the body has covered this displacement x2 minus x1. So what I mean to say is that in this case, the slope of the position time graph will give us the speed of the body. The slope of the position time graph will give us the speed of the body. And the slope of a straight line is always constant. Whether you take this part, this part, this part, the slope will always remain constant. So as a result, if position time graph is a straight line, it means that speed is constant. So between any two coordinates, if you determine the slope, that will give you the speed. Let's check it out, right? Suppose this is point O, A, B, C, D. I'll try to convince my point. I'll try to prove it mathematically. So what to do is, let's find out the slope between the points OC. 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 O is the initial point having coordinate 0, 0. C is the final point having coordinate 3 and 30. This is x1, y1. This will be x2, y2. What's the formula for this slope? x2 minus x1. Look, x2 minus x1. Rather, y2 minus y1 divided by x2 minus x1 in terms of y and the x coordinate. So this is y-axis, this is x coordinate, right? So 30 minus 0 divided by x coordinate, that is 3 minus 0. What we are getting is 10. And this is in meter and this is in second. So numerator that denotes position, it will be in meter, and denominator denotes time, that will be in second. So it will be meter per second. Look, speed of the body, that's 10 meter per second. Let's consider slope of the same graph between the position B and C. Between B and C. B is the initial point, C is the final point. Right? x1, y1 and this is x2, y2. So slope is y2 minus y1 divided by x2 minus x1. So what you get is slope. First write the difference of the y coordinate, 30 minus 20, divided by difference of the x coordinate, 3 minus 2. So that will give us 10 by 1, that is again 10 meter per second. Let's consider the slope from A to B. Please students try to get convinced. Let's consider the slope from A to B. A is the initial point, B is the final point. So x coordinate is 1, y coordinate is 10, here x coordinate is 4, y coordinate is 40. Slope is y2 minus y1 divided by x2 minus x1, right? So y2 over here is 40, this is y axis, this is the x axis. So 40 minus 10, right, 40 minus 10 divided by 4 minus 1. So that will be 30 by 3, which will give us 10 meter per second. So what we have derived mathematically, or what I have tried to convince you, is that first, the slope of a straight line is always constant. It is of no consequence, or it is immaterial whether you consider points OA, OB, AC, BD, CD, whichever 2 points you consider. If it's a case of a straight line, if those 2 points are lying on a straight line, then its slope would be constant, right? So position time graph, it's a straight line representing constant speed. Second important point, what we have proved is the slope of position time graph, that will give us speed of the body. That is what we have proved, right? So student, always remember, in case a body is in uniform motion, its position time graph would be a straight line inclined towards the time axis, and the slope of position time graph will give us the speed of the body. If it's a straight line, then the speed of the body must be constant, which is what we proved over here time and again. Clear? And slope is y2 minus y1 divided by x2 minus x1. That also will prove in the mathematical section, right? This is the y coordinate and this is the x coordinate. Here this y coordinate represents position, which I have denoted by x. And here x coordinate represents time. Clear? So this position, that is x2 minus x1 divided by time, that is t2 minus t1. So actual length covered divided by actual time taken. That obviously will give us speed. So this is regarding the position time graph of a body having uniform speed, right? Now let's consider the velocity time graph of a body having uniform motion. Let's see. Again, let's consider the same case. What we have considered was a body to be moving with a constant speed of 10 meters per second. Let's imagine the same case. Let's consider the body to be moving with constant speed of 10 meters per second, right? Since it is a uniform motion, its speeds need to be constant. Now we need to determine the velocity time graph. Okay. One of the coordinates is velocity, one of the coordinates is time. Time coordinate is conveniently always represented along the horizontal axis, right? While the other physical coordinate is normally represented in the vertical axis. So let's consider this. Speed time. This is speed, suppose v. Obviously, SI unit would be meter per second, and this time in seconds. So initially, or rather after a duration of 1 second, its speed is 10 meters per second. After the lapse of 2 seconds, it will have the same speed. Speed is constant, it is not varying. Even with the passage of time, even with the lapse of time, the speed of the body remains constant. So even after 3 seconds, 4 seconds, 5 seconds, the speed will remain same. So after getting the coordinates, we can easily plot the graph. Let's see what's the nature of the graph over here. This is time. Obviously, in second, you have to mention this is velocity or speed. In one-dimensional motion, velocity is equal to speed. So either write speed or velocity, it's the same thing in 1D case. it will be in meter per second, right? So this is 1 second, 2, 3, it should all have equal gaps. Over here, suppose it is 5, it is 10, 15 meter per second, 20 meter per second. In short, the gaps should be equal. Let's plot the graph. Initially, t equals 0, the body is having the same speed. At t equals to 1, the speed of the body is 10, like this. This is the point. Ordinate and abscissa, that is 1, 10. This is the point, right? 2 seconds, the speed will remain same. This will be it. This coordinate is 2, 10. 3, 10, again 3, t is 3 and v is 10. This is 3, 10. Then 4, 10. This is 4, 10. Then 5, 10 and so on. This is 5, 10. So if we join these points, we will obviously get a straight line parallel to the time axis. This is a straight line parallel to the time axis, indicating that the speed of the body is constant during uniform motion. So that's the conclusion. The position time graph is a straight line inclined towards the time axis. The velocity time graph is a straight line parallel to the time axis, right? So it is parallel to the time axis. Now there is a very important thing to be understood. Here, the area of velocity time graph, that will give us the distance or the displacement covered by the body between the two given intervals of time. I'll convince you. Suppose we are asked to find out the distance or displacement covered by the body during interval t equals to 3 seconds to t equals to 5 seconds. My question is, suppose we are going to find out the distance or the displacement covered by the body during the time interval t equals to 3 seconds to t equals to 5 seconds. So this is t equals to 3 seconds, this is t equals to 5 seconds. So what to do is shade this portion. The area of this portion will give you the distance covered by the body. We'll prove it. So basically the point is distance covered would be equal to area of the shaded portion of VT graph, velocity time graph. Distance covered would be equal to area of the shaded portion of the VT graph. Right? Let's check it out. Look, what is the dimension of this side? It is 2 units. It is 5 units, it is 3 units. So what's the gap between these two? It is 2 units. 2 units. Or rather 2 seconds. What's the gap between these 10 units? Okay. Area. It's in the form of a square, rectangle, whatever. So its formula is length into breadth. So 10 into 2. 10. What will be its unit? 10. It's in meter per second. Over here, it's 2 units. Unit is second. Right? Second per second get cancelled. What do you get? 20 meters. So meter is the unit of distance. So the area of VT graph, velocity time graph, must give the distance covered by the body between the two given intervals of time. That is what we have found. You can make use of this result directly as well. You can verify this result. We are all aware, distance, it's given by speed into time. So, suppose we need to do this quotient directly without the help of graph, then also we can do it. The result should tally with any of the method, right? So, what's the time interval? In 2 seconds, what will be the distance covered? That is what we are supposed to calculate. What is the speed of the body? 10. And what is the time that has elapsed between t equals to 3 seconds to t equals to 5 seconds? 2 seconds has elapsed. So, what is the duration of time? 2 seconds. So it will be equal to 20 meter. Look, both the results are in agreement with each other. So you can find it mathematically, you can find it with the help of graph as well. So what we have verified is the area under velocity time graph will give the distance covered by a body between the two given intervals of time. In order to convince you again, let's take another example. Let us consider we need to find out the distance covered by the body between t equals to 1 to t equals to 4 seconds. During this time interval, we are supposed to get the result. So what to do is, let's see how to proceed. So we are going to find out the distance or displacement in the time interval t equals to 1 to t equals to 4 seconds. This t equals to 1, this is t equals to 4. Okay. T equals to 1, t equals to 4. So this is the area, this is the shaded portion whose area is to be found. And the area of this portion will give the distance covered by the body between t equals to 1 to t equals to 4 seconds. Let's check it out. So, distance covered in this case would be area of this portion. What is the dimension of this part? It is 10 units. What is the dimension of this part? From origin it's 4 units, from origin it is 1 unit. So this is 3 units. So it's in the shape of a rectangle. Its area is length into breadth. So it is 3 units, it is in seconds, and breadth, that is in 30 meter per second. Second per second get cancelled. We will be left with meter. So it is 30 meters by graph. Now let's check it whether we have done it correctly or not. So distance, it is equal to speed into time. Let's make use of this formula. What is the speed with which the body is moving? 10 meter per second. What is the duration of time from t equals to 1 to t equals to 4 seconds? It is 3 seconds, right? So this is 3. So it will give us 30 meters. So either solve it mathematically or solve it graphically. So why we have done all these things is to convince you that the area, mark my words, the area under velocity time graph will give us the distance covered by a body between the two given intervals of time. Right? So whatever we have discussed, let me recapitulate it. Uniform motion means the body covering equal distances or equal displacements in equal intervals of time. However, the time intervals may be small, right? And what are the important characteristics? First, the speed of the body should be constant, right? Second, what is the second point? Second point is the position time graph. It should be always a straight line, inclined towards the time axis. And with the help of position time graph, its slope that gives us speed or velocity of the body. Velocity time graph, what will be the nature? It will be a straight line parallel to the time axis. And what is the significance of this graph? The area under velocity time graph, that will give us the distance covered by the body between two given intervals of time. And I must remind you, we are dealing with the case of motion in one dimension, when the body moves along a straight path. So whenever a body moves along a straight path, then speed of the body is equal to its velocity. So there shouldn't be any confusion, right? So I hope, students, you must have understood all the concepts involved in this. We'll continue with the other type of motion in the next session, right? Till then, go through these topics thoroughly.